Questions on the homework before we get started? So the first thing we have, this is already listed in your note sheet, don't have to fill it in, is our properties of rational exponents. Properties of exponents. Now, our properties of exponents, we've had this before. We've talked about this before. We've worked with this on and off for a decent bit. The first one we have is product of powers. If we have two things being multiplied together, we have like bases being multiplied together, we have the exponents. Power of a power, a to the m to the n. If we have a power of a power, those powers multiply. Power of a product, if I have two things being multiplied together inside of parentheses and they are put to a power, we apply that power to both terms. Negative exponents, if I have a negative exponent, to make that exponent positive, we move it from the top of the fraction to the bottom or bottom to the top. Zero exponent. Anything to the zero power is 1 except for 0. 0 to the 0 does not exist. We can't have 0 to the 0 power. Quotient of a power. If I have two things being divided, have like bases being divided, we subtract the exponents. Power of a quotient. If I have two things being divided to the same power, we can apply that power to both terms. Or vice versa, we can remove that power from both terms. We can go from one side to the other. Simplest form, we're not going to worry about this for now because the simplest form, we'll come back to it. We'll talk about it tomorrow, but it really applies mainly to radicals, and we have our square roots, cubed roots, fourth roots, our radical terms. And what we're focused mainly on today is properties of rational exponents, how we work with these here. Now, the first one we have is 7 to the 4th, 7 to the 1/4 times 7 to the 1/2. When we multiply like bases, we add the exponents. So what we're saying here is that I actually have 7 to the 1/4 plus 1/2. So if we're multiplying like bases, we're going to add those exponents. So now we just need to do 1/4 plus 1/2. Well, 1/4 plus 1/2 is indeed 3/4. So that tells me that we actually have 7 to the 3/4. Questions on this here? We ready for the next step? That's it. Because we're not asked to solve it, we're just asked to simplify. We simplify down. We're going to simplify as far as possible. We don't want to approximate. We're not going to round. It's just 7 to the 3/4. Questions on how we got A? We ready for B? 6 to the 1/2 times 4 to the 1/3, all to the second power. Now, 6 and 4 are not like bases, so we can't add those exponents. We can't really do much with it. We can't move it in the opposite direction. We can't take the 1/4 and 1/3. We can't remove them because 1/4 and 1/3 are not the same. However, we do have power of a product. If I have two things being multiplied together and they are both put to a power, I can apply that power to both terms. In this case, that power is 2. So according to our power of a product, I can apply that power of 2 to both terms, our 6 to the 1/2 and 4 to the 1/3. Be nice if I actually wrote that exponent correctly. Yep. Said it correctly, wrote it wrong. Questions on what we've done so far? Powers of powers multiply. So our 6 to the 1/2 squared would be 6 to the 1/2 times 2. And 4 would be to the 1/3 times 2. Powers of powers multiply. 1/2 times 2 is what? One half times 2 is 1. We have 2 halves, they make a whole, yes? So it's 1. 1/3 times 2 would be 2/3 because we multiply top with top. So the 2 would multiply with the 1 on top, giving us 2. Denominator would still be 3, giving us 6 times 4 to the 2/3. 4 to the 2/3 does not reduce, it doesn't simplify, it would just be an irrational number. So there's no way we can simplify 6 times 4 to the 2/3, it's just 6 times 4 to the 2/3. Simplified as it gets. Bless you. Questions on this here? Now, the order in which we apply these properties really doesn't make a big difference. It's just which ones we see, which ones we can apply. We're going to apply them in the order that we see them. Because if we look at C, 4 to the 5th times 3 to the 5th, all to the negative 1/5, we want to simplify this and rewrite it. Because there's a few different things we can tackle first. We can try to tackle the negative exponent first. We do have both of those terms to the same power. We also have a power of a product. For this one here, let's tackle power of a product first. Since I have both of these 4 and 3 to the same power, we can say this is the same as 4 to the 5th to the negative 1/5 times 3 to the 5th to the negative 1/5. When I have two things being multiplied together and they're both put to the same power, we can apply that power to both terms. And this is specifically with product. If it had been 4 to the 5th plus 3 to the 5th, we cannot do this. It's only if they're being multiplied together inside those parentheses. Power of a power, we multiply, so I'd have 4 to the 5th times negative 1/5 times 3 to the 5th times negative 1/5. Powers of powers multiply. Five times negative 1/5. We know it'll be negative, yes? Because it'd be 5 over 5, which is 1. So they actually work out to both be negative 1. Can't leave an exponent negative. So to make it positive, we've got to do what? Move it from the top of the fraction to the bottom. So when I do that with the 4, let's spin the page a little bit. We'd have 4 on bottom. But I'd also have to do it with the 3, which is really telling me I have 1 over 4 times 3. What is 4 times 3? So this reduces to 1/12. Questions on what we did here? Now, I did say that there was multiple ways we can do these, yes? Interestingly enough with this here, the 3 and 5 are both to the 5th power, yes? According to our power of a product, if I have two things multiplied together, both to the same exponent, I can apply that exponent to both terms, yes? The converse is true. Since they are both to the 5th power, means we can remove it, which is nice because now I have 4 times 3 to the 5th to the negative 1/5. What's 4 times 3? 12. Powers of powers? Multiply, yes? Did we say in that definition it had to just be 2 powers? No, because really we have 12 to the 1st to the 5th to the negative 1/5. Powers of power still multiply. It doesn't matter how many we have. So really we have 12 to the 1st times 5 times which is still 12 to the negative 1, which is still 1/12. Still get the same answer either way. Questions on this here? Be ready for the next one. Five over 5 to the 1/3. When we divide like bases, we subtract the exponents. When we divide like bases, we subtract the exponents. Well, since we're not dealing with integer exponents, it might be better to do this by the definition. Numerator exponent minus the denominator's exponent. And what is the numerator's exponent in this case? 1. It's not written, so it's understood to be 1. So we have 5 to the 1 minus 1/3. 1 minus 1/3 is 2/3, telling us that we have 5 to the 2/3. And that's it. Questions on this here? Questions on anything we've done so far? I think for the most part we have a good handle on most of these properties, yes? Interestingly enough, we could have actually done this, you don't have to write this, without using the quotient property at all. All I have to use is product property. When we multiply like bases, we have the exponents and our negative exponent property. If I want to move a fraction from the, or move a term from the bottom of the fraction to the top, we take the exponent, change it from positive to negative or negative to positive, which means I can move the 5 to the 1/3 from the bottom of the fraction to the top. I now have two bases, two of the same bases being multiplied together. And according to the product property, we add the exponents, which would be the same as saying 5 to the 1 minus 1/3 when we divide like bases, we subtract the exponents. Exact same thing. I would use the quotient product, really overdoing that. Only times I do that is when I forget what the quotient property is, but I remember the other two. Questions on D? E is a little bit interesting. We do have two things being divided to the same exponent, yes? Now, I would only do this next step if the numerator's base and the denominator's base are both divisible. Is 42 divisible by 6? 42 divided by 6 is what? 7, yes? That's nice, because if there's a way that I can get it just 42 over 6, that means they'll reduce. I don't have fractions. We don't have to worry about that. And one thing that's nice is that 42 and 6 inside these parentheses are both to the same exponent, yes? So just like we did before with that product, we can actually pull that 1/3 away from the numerator and denominator, telling us that we have 42 divided by 6 to the 1/3 squared. And 42 divided by 6, as we already said, is 7. Powers of powers. Multiply. Telling me this simplifies the 7 to the 2/3. Questions on this here? Don't think it would ever happen to y'all, but it might. We get finished simplifying this and we're not sure we got the correct simplification. Do we have a variable written anywhere in that last one? Well, no, that's straight numbers all the way through, yes? 42 to the 1/3 over 6 to the 1/3 squared. I can grab a calculator and say 42 to the 1/3 over 6 to the 1/3 squared. And it tells me it's this decimal, which doesn't mean a whole lot to us. But my final answer for this was 7 to the 2/3, yes? Well, lo and behold, those are the exact same value, so therefore they must be equivalent statements. Easy way to check, just make sure we got it right. I just stick both of them in the calculator because we just have numbers, no variables. See, do they have the same expression, same value? So 7 to the 2/3 is the last answer. Questions on these here? Two to the 3/4 times 2 to the 1/2. When we multiply like bases, we add the exponents. So we have 2 to the 3/4 plus 1/2. This one we just need to add 3/4 and 1/2. I believe we should get 2 to the 5/2. Because 1/2 is the equivalent of 2/4. So 3/4 plus 2/4, 3 plus 2 is 5. Questions on number 1? Number 2, 3 over 3 to the 1/4. When we divide like bases, we subtract the exponents. Now, since the exponent on top is not written, it's understood to be 1. So we have 3 to the 1st divided by 3 to the 1/4, which is equivalent to 3 to the 1 minus 1/4. And 1 minus 1/4 is 3/4. 3 to the 3/4. Questions on any of those here? (20 to the 1/2 over 5 to the 1/2, all to the 3rd. When they're both to the same exponent, they are both to the 1/2 power, and since 20 is divisible by 5, first thing I would do is pull that 1/2 power away from both of them and rewrite it as 20 over 5 to the 1/2 to the 3rd. And again, just like before, the reason we're doing this is that 20 over 5 is 4. Interestingly enough, we've got 4 to the 1/2. That simplifies. Because 1/2 power says square root. What's square root of 4? (20 to the 1/2 over 5 to the 1/2 cubed. Not what I wanted. Questions on any of these so far? Let's look at the next one. 5 to the 1/3 times 7 to the 1/4, all to the 3rd. We have two bases or two numbers being multiplied together, but since they're not like bases, we cannot add the exponents. On one of the previous ones where we were able to pull the exponent away from both and multiply and then simplify down, we can do that because the exponents were the same. 1/3 and 1/4 are not the same exponent. So all we can do is our power of a product. And apply that exponent of 3 to both of them. So we have 5 to the 1/3 to the third times 7 to the 1/4 to the third. Powers of powers. Multiply. So we have 5 to the 1/3 times 3 times 7 to the 1/4 times 3. 1/3 times 3 is 1, so it just gives us 5. Times 7, 1/4 times 3 would be 3/4, giving us 5 times 7 to the 3/4. Questions on those here? How do we feel with these here? Feel good with these here? Yeah, 3 to the 5/2. I think we feel pretty good with these here. I mean, we could go through and work through all these here. But I'm going to give you the rest of the class time to work on problems 3 through 10. 8 problems.